We're asked to give the loose dot structure for this ion. The first, we have one chlorine atom. It's in group 7, so it contributes 7 valence electrons. We have 2 oxygen atoms in group 6, so that contributes 6 valence electrons each. Okay, however, we have to deal with the fact that we have a net charge. The fact that we have a positive charge indicates that we have lost 1 electron. So we need to subtract an electron from our total. Therefore, we have a total of 16 valence electrons. And I'm going to put them in pairs. It makes it easier to count. So we have 16 valence electrons, or 9 electron pairs. The first step is to connect up the atoms. So we're going to connect our atoms. Now we want to complete the octet of our outside atoms. We've used 2 of our 9 electron pairs. So that's 2, 3, 4, 5, 6, 7, 8. Now we've used 8 of our 9 electron pairs. We only have 1 electron pair left to contribute to the octet of the chlorine atom. We're going to look at the chlorine atom. We see it has 3 electron pairs. We remind ourselves that bonding electrons count towards the octet of each atom that's involved in the bond. So we have 2, 4, 6 electrons that count towards the octet of the chlorine atom. The central chlorine atom is electron deficient by 1 electron pair, so we need to have a double bond. We're going to cause one of the electron pairs to move from being a lone pair to a bonding pair. Now we can rewrite our compound, and we see that our chlorine atom now has a complete octet. We have 1, 2, 3, 4 electron pairs. That's an octet. We also have an octet on this oxygen atom, 1, 2, 3, 4, and this oxygen atom has 1, 2, 3, 4. Note, we would have been entirely correct if we wanted to write the double bond on this side with a single bond over here. Either answer is correct and acceptable.